Good morning, everyone. So, in this lecture, we have to see the comparison between Wi-Fi mesh, Bluetooth mesh, and the Zigbee. So, the comparison chart is given, and there is a definition between all of things and with their strengths and weakness. Okay, we can see the Zigbee and all these things. So, let's start. So, first one, the comparison. So, comparison of Wi-Fi mesh, Bluetooth mesh, and the Zigbee one. So based on comparison chart, we have to see what are the properties and what are the behaviors. So the feature in this section, in this column, we see the features of all of based on this which can compare. In the feature of Wi-Fi mesh, comparison of Bluetooth mesh, and this one is Zigbee. Okay. So the frequency band, based on frequency, we can see that Wi-Fi is ranging from the 2.4 to 2.6. We simply remember that remember that we are using Wi-Fi 6. Okay, so the Wi-Fi frequency band ranging from 2.4 to 5 gigahertz. Okay, Bluetooth mesh working on 2.4 gigahertz. Okay, and Zigbee also 2.4, most common 2.4. After that, we have to see the data rate. So the data rate in Wi-Fi mesh is very high. Okay, so it's very high. It is at 100 to 600 MB per second. Okay, in Bluetooth less than 2 MB per second, but Zigbee is used in our smart meter, so that's why the data speed rate is less as compared to both of them, Wi-Fi mesh or Bluetooth mesh. Okay, 300 30 to 50 meter. Okay, Wi-Fi ranging from 30 to 50 meter as we see in our college hostels, and Bluetooth 10 to 30 within the rooms. Okay, and the within the rooms, and the Zigbee is also 10 to 20 meter. Okay, lesser than this one. Power consumption, the power consumption is high in Wi-Fi, very low in Bluetooth, very low. Okay, and low in Zigbee one. Okay, the network topology things. So the network topology, the Wi-Fi is a mesh network type. Okay, and manage flooding mesh. Okay, the Bluetooth use manage flooding mesh and multiple multi-hop mesh. Okay, AODV based. Okay, network size will be small and medium. Okay, network size will be small and medium, very large. Okay, small medium, like 50 to 100 nodes. Okay, in this. And when we're talking about network size, when we're talking about the Bluetooth, it's up to 32,000 nodes. It's very high, very large. Okay, and and in Zigbee there's 65,000 nodes, so it is largest among all these things. So network size of the Wi-Fi is less, and in Bluetooth is second position, and very high in the Zigbee. Okay, latency and a very low latency. Okay, medium to high approx. Bluetooth has medium to high latency, and there is a medium latency in the Zigbee portion. Okay, when we are talking about the reliability, in which Wi-Fi is more reliable as compared to the Bluetooth, and Zigbee is also more reliable than Bluetooth. So like this one, this is the comparison. Okay, after that, idea for what? Uh, so idea for what? High speed, ideal for what? What, in which place we have to use this one? So simply use at high speed and home and internet. Smart lighting, Bluetooth in the smart lighting beacons and the wearable devices in which we have to connect the Bluetooth. Home automation things, sensor, and the industry in which we use Zigbee. Okay, the Wi-Fi cost is very high as compared to Bluetooth, and in Zigbee we have to less costly as compared to both of them. So what is the comparison based on? First of all, frequency band, then range in which will Bluetooth have Bluetooth in which Wi-Fi has power consumption. Okay, higher in the Bluetooth as compared to this one. Topology things. Okay, and Network size in which the smaller one, network size in which Bluetooth have a smaller network size, okay, and larger in the Zigbee portion. Latency, low latency in which medium to high and high. Okay, reliability, this one high, this is medium, and this is high. Ideal for the home speed and these things. Okay, smart lighting and the home automation and the industry things. Okay, cost, we see the cost that Wi-Fi is Wi-Fi is highly costly as compared to Bluetooth, and Zigbee is very less. Okay, let's see Wi-Fi mesh. Okay, so Wi-Fi mesh use multiple router acting as a mesh network to provide a seamless wireless communication. Okay, Wi-Fi mesh use multiple router acting as a mesh and provide a seamless wireless communication. It offers the high throughput or low latency, which make it suitable for the broadband and high speed IoT application. Okay, Wi-Fi mesh basically use multiple router acting as a mesh, and which provide a seamless wireless communication. Okay, coverage, and it offer the high throughput, low latency, and make suitable for the broadband and the high speed IoT application. Okay, and the strength are as follow. The strength of this device is very high throughput. Okay, good for the video streaming, camera. We are using Wi-Fi for the streaming one, and heavy IoT uses. Okay, easy home and office setup. The strengths are as follows. Weakness, because every component in the world have their own weakness and the strength, and the weakness is high power consumption. Okay, fewer support node as compared to BLE and Zigbee. Okay, more prone to the interference, more prone to the interference. Okay, these are the strength and the weakness. So Wi-Fi mesh use the multiple routing, uh, working on the mesh node, acting as a mesh node, which provide a seamless coverage, and it offer the high throughput low latency, which makes suitable for the broadband application and high speed IoT application. Okay, strength are the very high throughput. Okay, good for the streaming one, camera, and heavy IoT devices. Easy to set up in the home and offices. Weakness, high power consumption, fewer supported for the nodes as compared to BLE, and this one more prone to the interface. Okay, Bluetooth mesh, and second one is Bluetooth mesh. Summary, a comparison chart. Now this is Wi-Fi mesh and now Bluetooth mesh. What is Bluetooth mesh? So Bluetooth mesh use managed flooding mechanism. Okay, it use managed flooding mechanism, which where the nodes rely message. Okay, and it is designed by extremely low power consumption and support a very large network. Okay, so Bluetooth mesh managed by the flooding mechanism where node are relies message, and it is designed for the extremely low power consumption and support very large network. Okay, what are the strengths of these devices? So extremely low power consumption, support hundreds of nodes, easily uh, commissioning with smartphone. Okay, easily commissioning with the smartphones. Okay, every device has their own strength and weakness. So weakness are as follow: the low data rate. Okay, higher latency with multi-hop communication. Okay, not suited for the heavy or real-time data transfer. So we simply send simple data and simple file. Whenever the real-time and high size data file have to transfer, then this Bluetooth mesh is not suited. Okay, so what you have to write: Bluetooth mesh use managed by the flooding mechanism where the node relies on masses, and it is designed to work for the extremely low power consumption and support very large network. Okay, and the strength has extremely low power consumption, support thousands of node, easily commission with the commissioning with the smartphones. Okay, because low data rate, high latency with the multi hops communication, not suited for the heavy or real time data transfer. Okay, and third one is a Zigbee. So what is Zigbee? Zigbee mesh. So Zigbee mesh use AODV based routing. Okay, with the coordinator. routing and end device forming and robust IoT mesh. Okay, the Zigbee use AODV mesh based routing with coordinator, router, and end device forming a robust IoT mesh, and it is widely used in the home automation and the industrial IoT. So it is widely used in the home automation and the IoTs. Okay, since are as follow: stable and reliable multi-hop routing. Okay, stable and the multi-hop routing feature, low power, ideal for battery power sensor. Okay, support large network. Okay, weaknesses, need a coordinator. So for the Zigbee, we need a coordinator and the routers. So Zigbee mesh use AODV based routing with coordinator routes and device forming a robust IoT mechanism mesh. Okay, it is widely used in the home automation and the industrial IoT. Okay, suitable and ideal for the multi-hop routing and the low latency, low power, and the ideal for the powered battery sensor, largely support. And in this weakness is the need coordinator. Okay, coordinator low data rate, possible interference in 2.4 gigahertz bands. Okay, so best choice summary in which I have to choice. Okay, so this one is that. So best on Wi-Fi mesh, best for the high speed broadband video and the high IoT task. Okay, Bluetooth mesh is best for the low power lightning backbones and the wearable networks. Okay, and Zigbee is best for the reliable smart home and industrial IoT sensor deployment. Okay, so in this PDF, we understand the comparison between Wi-Fi mesh, Bluetooth mesh, and Zigbee mesh by the comparison chart of between the frequency, data rate, range of hops, power consumption, topology, network size, latency, reliability, ideal for, and cost. After that, we understand Wi-Fi mesh is use multiple routing acting as a mesh node, and which provide a seamless wireless communication with the offer the high throughput, low latency, suitable for the broadband application. Plus provide water property, strength hard, provide high throughput, good for the video streaming, cameras, and heavy IoT uses. Okay, easy to set up in the room and office. But one demerit are as follows: the high power consumption, fewer supported node as compared to BLE, more prone to the interface. Okay, Bluetooth mesh. For the Bluetooth mesh, use managed flooding mechanism. So it managed by the flooding mechanism where the node relies masses, designed for the extremely low comparison consumption and support very large network. Okay, and extremely low power consumption, support thousands of node, easy of commencing with the smartphone. Weakness, low data rate, higher latency with the multi-hop communication, not suited for the heavy and real-time data transfer. Third one is use AODV routing, based routing, coordinator and router, and the end device forming a robust IoT mesh. Okay, it is widely used in home automation things. Stable and reliable multi-hop routing, low power consumption. Okay, support large network. And the weakness is it need coordinator, low data rate, possible interface in the 2.4 bands. Okay, best choice whenever we have to choice Wi-Fi ness. So whenever we need the high speed broadband video, the heavy IoT users. Okay, Bluetooth mesh best for the low power lightning backbones wearable networks. Zigbee is best for the reliable smart homes and industrial IoT sensor deployment. Okay, so we cover this one. So let's move for the next PDF. Next PDF. Zigbee network. Zigbee network. Zigbee. Okay. now now we have to see the Zigbee network. So what is Zigbee network? Okay, let's see. So Zigbee network. So Zigbee use a AODV routing based and need a coordinator and the router. Okay, so this is Zigbee coordinator. This one is Zigbee coordinator. Okay, and Zigbee router. So it is coordinator, and this one is the Zigbee router. Okay, and Zigbee end devices, and these are the Zigbee end devices. Okay, so that's why the number of node in Zigbee is higher as compared to the Bluetooth and the Zigbee and something Bluetooth and something. So Zigbee network, first one is star, tree based or mesh based. Okay, the based on star, easy to synchronize. Pros, what are the pros and cons? Okay, so if we use star based design, so it is easy to synchronize, support low power operation and low latency. Okay, but cons is small size. Star is small size. When tree based, low routing cost, can form to support sleep mode. Okay, can form super frame to support sleep mode, allow multi-hop communication. Okay, and allow multi-hop communication. And the cons are route reconstruction is costly. Okay, if any route is disturbed, then the route construction is costly. Latency may be quite long. Okay, because a tree based, whether it have to decide where we have to go, which path we have to select. Okay, that's why this having a quite large latency. Okay, in mesh based, robust multi-hop communication network is more flexible and lower latency. Okay. Mm. Cannot form a super frame, so cannot form like super frame like tree based, thus can support sleep mode, but it can support sleep mode. Okay, a route discovery is costly. In mesh based design, and route discovery is costly and need a storage for the routing table. So we need a storage for the routing table, because route discovery of the route is simply costly in this one. So star, tree based and mesh based, easily to synchronize, support low operation, low latency. And cons is that small size. But in tree based, low routing cost, because it can support a super frame. It's super frame to support a sleep mode and also allow multi-hop communication. But the cons is that route construction is costly and latency may be quite long. Okay, but in mesh, robust multi communication network is more flexible. Network is more flexible and low latency. But problem is that we cannot make a super frame, and it but it can support sleep mode. Okay, route discovery is costly and need storage for the routing table. Okay, need storage for the routing table. Okay, Zigbee versus IoT. In this we have to study. So this one is the Wi-Fi on this one. So we have to study Zigbee protocols. This one is Zigbee protocol. So notes on the Zigbee protocols. Let's see. So Zigbee is a low power, low data rate, short range wireless communication protocol used in IEEE standard for the 802.1.5.4 standard. Okay, and it is widely used IoT applications such as home automation, things, sensor networking, smart energy, and the industrial monitoring. Okay, so Zigbee is a low power, low data rate, and short range wireless communication protocol based on the IEEE standard 802.1.5.4. Okay, it is widely used in the IoT applications such as home automation, sensor networking, smart energy and industrial monitoring. Okay, so in this we can see that different layer. Okay, this one is physical layer. Okay, after that MAC layer, after network security layer, and the application framework and the application. So uh, till here we use IEEE standard of something. It's not this one, and this one is a Zigbee stack. Okay, and this is application and this hardware portion. Okay, this one is hardware, this one is a Zigbee stack, and this is application. Though these specification lies between Zigbee specification lies from this layer to this layer. So when we have to make the when we have to make the protocol stack of Zigbee, physical, MAC, network and security layer, and application framework, and then application. Okay, so IEEE 802.1.5.4 physical layer. So in this we have to discuss actually what this layer do. So handle the modulation things, demodulation things, spreading and decoding. Okay, spreading and coding. Provide a 60 channel of 2.4 gigahertz ISM band. The channel ranging from the 11 to 26. Okay, provide, so it handle the modulation, demodulation, spreading and coding things, and provide a 16 channel in the range in the band of this one. The channel line is between 11 to this one, so 16 channel. Okay, and use OQPSK with the DSS D triple S, OQPSK with the D triple S, offering a data rate of 250 kilo 250 kbps. Okay, support energy detection, link quality detection. Okay, and a clear channel assessment. Okay, clear channel assessment. Okay, support energy detection. Okay, link quality detection, and clear channel assessment. Okay, what this layer simply do: handle the modulation, demodulation, coding things, and provide 16 channel in the range of 2.4 gigahertz ISM band, channel ranging from the 11 to 26. Okay, use OQPSK with the D triple S. Okay, offer our data rate of 250 kbps. Okay, support link quality indication, energy detection, and the clear channel support assessment, clear channel assessment. Okay, after that the MAC layer. So when we move upward, we see the MAC layer, in which it is a standard of 802 1.5 15.4. Okay, so it provide a medium access using CSMA or CA. Okay, okay, support frame validation and optional acknowledgement. Okay, support frame validation and optional acknowledgement. Okay, handle um, beconing for the synchronization. Okay, support frame validation and optional acknowledgement. Frame validation, the frame validation things happen in the MAC layer. Okay, and the optional acknowledgement things. Okay, handle backconings for the synchronization, and provide a secure MAC frame using AES 128 encryption. So also support MAC frame. Okay, frame using AES 128 encryption. Okay, so these are the property of the MAC layer. After that, a Zigbee network and security layer, in which we have to see that in Zigbee network layer, in which manage the network formation, maintenance, and the routing thing. So in network layer, so manage the network formation, maintenance, and the routing thing. Okay, implement AODV based mesh routing. So as we studied previously. Okay, assign 16 bits sort address. Okay, assign 16-bit sort addresses. Okay, support star, tree, and mesh topology. Okay, and maintain the neighbor table. What does Zigbee network layer do? Okay, first of all, it manage the network formation, maintenance, and the routing. Manage the network formation, maintenance, and the routing. Implement the AODV based mesh routing. Assign 16-bit addresses. Okay. Support mesh and tree. Support tree mesh and topologies. Maintain neighbor table. Okay. All these things. So device. So the device type here. Okay. So Zigbee application layer consists of three components. Okay. Zigbee application layer consists. So application support layer APS. Zigbee device object. Okay. And application framework. Okay. So Zigbee application layer consists of three components. First of all, application support layer. Application support layer. Okay. Application support sub layer. Okay. Handle the binding, addressing, fragmentation, and reassembly thing. So handling the binding, addressing. So binding. Okay. Binding this thing. Okay. Then binding and addressing. Okay. And fragmentation reassembly thing. Okay. Application support sublayer. Okay. Zigbee device object in which manage the device role. Okay. Managing device role, discovery and network joining and leaving things. So first of all, it manage the device role. Okay. discover it and Discover and network joining and leaving things. Okay. This can be Zigbee device object. Okay. Application. So application framework, host application object defined using Zigbee cluster. Okay. Define using the Zigbee cluster library. Okay. Zigbee cluster library provide a standardized cluster such as on-off feature, level control feature, temperature management feature, or enabling the interoperability. Okay. So Zigbee application layer consists of three important things. That her first one is application support layer, sublayer. After uh, Zigbee device object and application framework. So Zigbee support layer in which the handle the bindings thing, addressing thing, and fragmentation and assembly things. Okay. Zigbee object define layer in which it manage the devices. Okay. Manage devices. After that, manage devices and discovery and the network joining and leaving things happen. Okay. Application framework, the host application object defined using Zigbee cluster, and Zigbee cluster provide the feature of on off level control, temperature management, and enable the interoperability. After that, Zigbee security. Okay. So Zigbee security, it is use AES 128 systematic encryption. Okay. It use AES 128 systematic encryption. Okay. Support network key and link keys. Okay. Support network keys and links keys. Okay. Keys and link keys. A trust center. The trust center, usually the coordinator, manage key distribution. Manage key distribution. Frame counter prevent reply attack. Okay. Frame counter prevent the reply attack. Zigbee security in which AES and systematic encryption support the network keys and link keys, and trust center manage the key and distribution. Frame counter prevent from the reply attack. So frame counter prevent from the reply attack. We remember AES support network key and link one, trust center manage the key distribution, and the frame counter and reply. This one. Zigbee security. Zigbee topology. So Zigbee use three type of topologies: star, tree, and mesh. Star mean that we have a coordinator as a central hub. So this one is a star. Okay. Tree mean hierarchical, in which this is okay. Is a tree based. So tree based. And mesh is highly reliable and fault tolerant and support multi hop. This one is a mesh like structure. Okay. So coordinator at the center, hierarchical, support highly reliable and fault tolerant, and support multi-hop routing. These are the topology of Zigbee. And in summary, we can say that in summary we can say that Zigbee protocol stack extend the IEEE standard of 802.1.5 115.4 physical and MAC layer with their own robust network security and application layer, and a low power design, mesh networking, and interoperability to make an ideal for the IoT application requiring us scalability and reliability. Okay, let's quickly recap. So we simply see the protocol, Zigbee protocol. So as we know that we simply read the introduction of Zigbee. So Zigbee is a low power devices and a low data rate in which short range wireless communication based protocol. It uses a IEEE standard 802. mm, So in a note for the Zigbee protocol stack, Zigbee is a low powered and data rate short range wireless communication based on protocol base of 802.115.4 standard, and it is widely used in the IoT applications such as home automation, sensor, and smart energy, smart energy, and industrial monitoring. The application, the protocol of this one is first one physical layer. Is a laser pen, fountain, brush pen, all this thing, pen point. No, you have laser. So okay. So Mac, a physical Mac network security and the application framework. So till this is a hardware system. This one is the Zigbee stack, and this one is the application. So we have studied that I physical layer. So in which the handling the modulation, demodulation, spreading and coding thing happen. So it provides 16 channel 16 channel on the 2.4 gigahertz ISMs. Okay, channel ranging from the 11 to 26. Okay, use OQPSK with the DSS and offering the data rate of something 250. Okay, support energy detection, mm, link quality indication, and channel clear channel assessment. Okay, thing CA. Okay, the role of the physical layer. Okay, and the Mac layer. So it provide Mac access. Provide a Mac access using CSMA or CA. Okay, support frame validation and the optical acknowledgement. Okay, handle beaconing and synchronization thing. Handle the beaconing and synchronization thing, and the app provide a secure Mac using AES. So provide a secure Mac using AES 128. Okay, then we move forward Zigbee network. So it manage the network formation, maintenance, and the routing thing. Network formation, maintenance, and the routing managed by the AODV mesh routing. Assign 16-bit of the address, support star, mesh, and the tree topology. Maintain the neighbor table. Okay. Device type, Zigbee coordinator, Zigbee router, Zigbee end device. Okay. And the Zigbee application are as follow. Zigbee application layer consists of the three things, three components. First one is application support sublayer, in which the handle the binding things, addressing things, fragmentation, and the assembly things. Okay. After that, a Zigbee device object. So it manages the device discovery and the network joining and leaving things. And application framework is the host application object using a Zigbee cluster library. So Zigbee cluster library provide a standard things for the cluster that provide a feature of on off, level counter and level control, temperature management, and enable the interoperability. Okay, what is Zigbee security? So Zigbee security use AES 128 encryption and a systematic encryption. Support a link key and link keys. Okay, support link keys and link keys. Okay, a trust center which manage all the key distribution, and frame counter managed from the reply attacks. Okay, and Zigbee topology where is the star coordinator as a hub, Star coordinator as a hub, tree hierarchical structure, mesh and highly reliable, fault tolerant and multi support. Okay. So Zigbee protocol stack extend the IEEE standard physical MAC with their own reverse network. Okay, application it is low power design and mesh networking and interoperability. It make a ideal for IoT application require the scalability and reliability. Okay. Okay, till here we have completed this one Zigbee network and fundamental of IoT basic level of this one. Now we move forward for the next topic is let's see the new PDF is compact compact note on the web of things. Okay, so compact note on the web of things. So what is web of things? So actually the typo thing is very small, so we have to focus what I've written. So web of thing is in the nutshell. So let's discuss. Typically, in the classical IoT project, a developer have a face and developer face a challenging situation. Typically, in IoT project, a developer face a challenging situation. They have to understand the heterogeneous technology landscape consisting of diverse IoT system and the services from the different vendor and manufacturer. Okay. Typically, a developer faced challenges during the IoT project that they understand a heterogeneous technology landscape consisting of diverse IoT system services and the different vendor and manufacturer. So these diversity include the variation in the communication protocol, data model or the payload data exchanges, okay, and security requirement. So to IoT application are usually developed using high effort applied to the narrow and specific use cases. So during their lifetime, such applications are difficult to extend and maintain to use. Okay. Uh, Actually, web of thing is a nutshell. Typically, a classical IoT project developer face a lots of challenges because to understand the technology landscape consisting of the diverse IoT system services from the different vendor and the manufacturer. These diversity include the variation communication protocols, data model for the payload data exchanges, and the security requirement. IoT application usually develop using high efforts applied narrow specific use. So during their lifetime, such applications are difficult to extend or manage and reuse. Okay. So so mm, as we see different application, different communication protocol. Okay, different application having different internet protocol, so it is difficult to understand different vendors and manufacturers technology landscape. Okay, so here we see so web of web of things IoT provides set of standardized technology building block that help to simplify the IoT application development by following the well-known successful web paradigm. Okay, so web of things provide a set of standardized technology building block that help the simplify the IoT application development by simply well-known and successful web paradigms. Okay, this approach they increase the flexibilities and interoperability. Okay, especially for the cross domain application, as well as enabling as well as enabling the reuse of established standard and tools. Okay, WOT unlock the commercial potential being held back by the IoT fragmentation. Okay. So, Web of Things provide a set of standardized technology building block which help to simplify the IoT technology application development by following the well and successful web paradigms. Okay, this approach increase the flexibility and interoperability, especially for the cross domain application, as well as enabling the reuse of established standard tools. Okay, so it increases the flexibility, interoperability, and it especially for the cross domain application, as well as enabling the reuse of the standardized standard tool. Okay, way of thing unlock the commercial potential being held back by the IoT implementation. Okay, so wave of things. So introduction. So wave of things is a W3 standard framework. So W3C standard framework. Okay, that provide a web technology such as HTTP, REST, JSON LD, and the web API to the IoT domains. Okay, wave of things is the W3 standardized application that applies to the web of technology such as HTTP, REST API, JSON LD, and web APIs to the IoT domain. So while the IoT connect physical device to the internet. So actually, what does IoT do? IoT simply connect the physical device to internet. Okay. So wave of thing focus on enabling the interoperability, discoverability, and uniform access through the heterogeneous IoT system. So WOT focus on interoperability between two heterogeneous IoT system. Okay, by making it interoperable, discoverable, and uniform access across heterogeneous IoT devices. Okay, the key concept of WOT is interoperability layer. Okay, the WOT provide a systematic layer over the IoT protocol like MQTT, COAP, HTTP, BLE, and Zigbee. So interoperability layer. IoT provide a systematic layer over IoT protocols like MQTT, COAP, HTTP, BLE, and Zigbee. Things description. In which things description? JSON LD based machine readable file that describe JSON LD is a machine readable file that describe the properties, action, and event of protocol building. Okay, thing description. JSON LD based machine readable file that describe. So we create a JSON LD file. Okay, through which a machine can read. Okay, machine can read, and that describe actually in the JSON LD file it describe the property, action, event, and the protocol building of anything. Okay. After that, uniform access. So WOT abstract the devices as a web resources. So WOT make a devices as a web resource, enabling the plug and play integration The key concept of the web interoperability. So WOT provide a smart systematic layer over the IoT protocol like MQTT, COP, HTTP, this thing description in JSON LD format, a JSON LD based machine readable file that describes the device property, action, event, and the protocol binding. Uniform access where the WOT abstract devices as a web resources enabling the plug and play integration. Okay. WOT interaction. So what is WOT interaction? So way of think introduce a simple interaction abstraction based on properties, event, and action. Okay, introduce a simple interaction abstraction based property like event, properties, event, and action. Any IoT network interface can be described in the term of this abstraction. So any IoT network So a simply quick recap. I think that screen is not visible. Way of things happen. Okay, typically classical IoT developer face lots of challenge in this situation. They have to understand the heterogeneous technology landscape and the consisting diverse IoT system and the services from the different manufacturer. This diversity include the variation in communication protocol, data payload, data exchange, and the security requirement. IoT applications are usually developed using high effort application and the narrow specific use case. During the lifetime, such applications are difficult to extend and maintain in use. So these are the application, these are the different protocols. Okay, these are the IoT devices. So IoT devices provide a set of standardized technology building blocks that help to simplify the IoT application development, as known as the successful web paradigms. Okay, this approach simply increase the flexibility in the cross origin domain application as well as enabling the use of standardized tool. So IoT unlock the commercial potential being held back by the IoT fragmentation. So WOT unlock the commercial potential fragmentation. And in introduction, we studied that the Internet Web of Things is a W3C standard net framework that implies the web applies technologies such as HTTP, REST, JSON, LD, and web APIs to the IoT domains. While IoT connect the physical device to internet, and WOT focus on enabling the interoperability, discoverability, and uniform access across the heterogeneous IoT system. Okay, the key concept is interoperability layer in IoT provide. So IoT provide a systematic layer over the IoT protocols, that is MQTT, COAP, HTTP, BLE. Okay, thing description. In thing description, we simply see that a JSON LD file have based on the machine readable things. The file describe the properties, action, event, and the protocol binding and the uniform access. The WOT abstract device as a web resources, enabling the plug and play integration. Okay, so here we see WOT interaction. So WOT interaction introduce a simple interaction, abstraction based properties, event and action. Any IoT interface can describe in the term of abstraction. Okay, by using this abstraction, the application has common anchor to retrieve the IoT services metadata as well as way to understand what and how the data and the IoT services function and the access. Okay, the interface can describe how the terms by using the abstraction application have anchor to receive the IoT services and metadata to understand that how the data and the IoT services function and access. Okay, so these are the IoT devices. So IoT devices having their properties, action and event. So property sensor value, config, parameter, status, read only, read write. Okay, action, brew coffee, fade in out, stop engine, long lasting devices, changing their property. Okay, event, fire alarm, door open, door stream, data, all these things. Okay, interaction things. Okay, so architecture of WOT. Okay, internet of web of things architecture. First of all, thing description. So core system semantic description of a device. So core semantic description. Okay, okay, we have to see the architecture of web of things. So in this, the first is things description, binding template, scripting API, and security model, and WOT runtime. Okay, first of all, it provide the things description. So things description in which a system semantic description of a device. So things description in the form of JSON LD, in which it describe the properties, action, and the event of any things. Okay, the core systematic description of device, and the binding template map TD to the real world protocol. So map TD to the real world protocol. Okay, first one is things description TD, and the binding template BT. Okay, binding template, you know, map TD, map things description to the real world protocol. After the scripting API. Okay, security model and the web of thing runtime. So javascript api for the javascript api for the javascript javascript API for the device orchestration. Okay, security model define authentication and the access control. Okay, scripting thing done by the javascript API. Security model thing define the authentication and access control. WOT runtime execute script and the manage interaction. Architecture W3C thing description. After that, binding template. After that, scripting API, security model SM, and the WOT runtime. So these are the architecture of the things. So WOT is a building blocks and the advantage and use cases. So we simply see that WOT is a binding block. So an IoT device metadata include all the information needed to enable the communication abstraction is documented what is called WOT things description. Okay. Mm, So let's see. So IoT device metadata including all the information needed to enable a communication as abstract the common abstraction is documented in what is called WOT things, and the things description is a central building block in the W3C way of thing, and can be considered as the entry point of IoT instances such as index.html of the website. Okay, it provide information on which data and function are provided. It provide a information on which the data and function provided, which protocol is used, is encoded and structured, and the security mechanism is used to control access, and further machine readable and human readable metadata. A thing description expressed in the JSON LD and can be used to provide by the IoT devices itself and hosted externally in the repository such as thing description directory. Okay, so IoT devices metadata including all information about the common abstraction in documentation, so that we call as a web of things description. So thing description is a basically central building block in the W3 web things, and consider for the entry point for of any IoT instances such as index.html website. It provides information about to which data and the function is provided, okay, which protocol is used, how data is encoded and structured, any security mechanism is used to control and access, and further machine readable and human readable metadata. The thing description is expressed in the JSON LD and can be provided by the IoT device itself and hosted externally in the repo. Okay, and here the in general in general WOT is protocol is agon, agnostic approach and provide a common mechanism to define how specific protocols such as MQTT, HTTP, COAP, or Modbus can be mapped to WOT interaction property action event abstraction. Okay. In general, WOT is a protocol agnostic approach. WOT is a agnostic protocol approach and provide a common mechanism to define how specific protocols such as MQTT, HTTP, COAP, or Modbus can be mapped to IoT interactions properties action event extraction. Okay, this map this map so this map and the protocol specific metadata are provided by the WOT binding template, and the binding template for this specific protocol provide a guideline how client can active and each WOT interaction abstraction through a common network facing interface. Okay, okay. Option WOT scripting file and building block to define the MK script, okay, for JavaScript API that closely follow the WOT things description, specific and support WOT interaction abstraction interface between the behavior implementation and the scripting based WOT runtime. Mm. Please note that, however, the implementation of WOT are not limited to the scripting environment. Programming language, um, programming language API in Java or C++ can also be drive WOT scripting API. Web of Thing also provide a guidance to the WOT security and privacy, and their WOT provide a guideline for the secure implementation and the configuration things. Okay, security and privacy should be considered in any system implement WOT. Okay, W3C. So in these three statements we simply understand that why WOT is known as a building block of building block, because IoT device because IoT devices metadata include all the information about the divided abstraction things and documentation, that is called we call thing description, and thing description is known as the central building block of W3C web things, and it is also considered the entry point for the all the IoT instances. Okay, it provides the information about the function properties and which protocol is used, how data is encoded, structure, security mechanism, everything. Okay, and control access for the machine to machine readable, human to readable metadata. A thing description is expressed in the JSON LD format and can be provided by the IoT device itself and hosted externally by the repo. Okay, in general, in generally we see that WOT is a protocol agnostic mechanism to define to specify to specify and to specify any protocol as MQTT, HTTP, COP, and Modbus map to the WOT and the interaction property and action event abstraction thing happen. Okay, so mapped protocol specific metadata, that is WOT building template, and the WOT scripting API is a building block defined the MK script in a Java in a JavaScript. Okay, It defines the interface and behavior and implementation of scripting things. So please note that, however, the implementation ability is not limited to the scripting environment. Programming language can also be derived by this one. Okay. And WT security privacy, they have their own guidelines for their security and this. So what is the advantage? So what is the advantage of WOT? Okay, high interoperability across heterogeneous IoT ecosystem. Right? High interoperability across heterogeneous IoT ecosystem, simplifies integration with the web and cloud application. Actually, it simplifies the interaction with the web and cloud application. First one, high interoperability across the IoT system. Okay, it simplifies the interaction with the web and cloud application. So web of things simplify the interaction of web to cloud application, and device become discoverable and self describing using JSON LD or thing description. It become more discoverable and self describing. Okay, reduce the vendor lock system and open standard. Okay, reduce the vendor lock and with the open standard. Okay, so what are the use cases of the WOT? Okay, smart home integration using multiple protocol, industrial dashboard. Okay, industrial IoT dashboard, smart city sensor network, smart city sensor network. So smart home integration, multiple protocol, multiple IoT dashboard, smart city sensor network, all these things. Okay, using the web paradigms, make flexible and interoperable, and they make a common domain, make a especially interoperable in the cross domain application, as well enabling the use of their standard tools. Okay, WT unlock the commercial potential being held by the IoT fragmentation. So definition, WT is a W3 and W3C standard framework which applied web technologies, that is REST, this one. And simply IoT device simply connect the physical device to internet, and WT focus on the enabling interoperability and discoverability and uniform access different heterogeneous IoT system. The key concept are interoperability layer, thing description, and the third one is uniform access. So interoperability layer provide IoT asymmetric layer over the IoT protocols in MQTT. Thing description in JSON LD provides a machine readable file that describe the everything property, action, and things event. Uniform access plug and play integration. This one, and in simply where WOT interaction. Okay, so WOT introduce a simple interaction abstraction on the property, event, and action, and IoT interface can based on their terms of their abstraction. Okay, by using the abstraction, application have a common anchor to retrieve the IoT services metadata and play and as well as understand what and how the data and the IoT services function and can be accessed. Okay, so interaction through the action and the property, action, and the event. Okay, the architecture of WOT is that things description, building template, scripting API, security model, and the WOT runtime. Thing description is core semantic description of the devices, building block, mapping, scripting thing, a JavaScript API, or this one security model, authentication, access control, execute script and manage things. Okay, why WOT is a building block? Because IoT device metadata, including all the information about the devices and common abstraction, is documented in what you call documented and what we call that is and web of thing and wave wave of things description. Thing description is the central block entry point, when as we call it entry point, everything general purpose. How web of thing is protocol is called like agnostic approach to provide a common mechanism, define how to specify the protocol using this one mapping thing, scripting thing, and the security thing. So advantage is that high interoperable across heterogeneous, simplify the interaction with the web and the cloud, Device become discoverable and self-describing using JSON LD. Reduce the vendor lock using smart home, industrial, and smart cities. Cloud edge orchestration orchestration using this scripting API. And simply, in summary, we have to say Web of Thing create a standard web-based abstraction layer top of the IoT using the thing description, building template, scripting API, uniform data model. WT make enable scalable, interoperable, and developer friendly. Okay. Okay. So let's stop streaming.